Hi, I just wanted to go over one of the problems. The first problem on the last homework. So you have a capacitor, and it's got certain potential difference, right? So there's like a battery over here, and just for fun, let's say that that's a 10-volt battery, okay? And it said that this was 3 millimeters, and then they put a slab in between. It was metal. But I want to actually just look at what does the graph of the potential versus sort of the distance between the plates look like. And we're just going to start with it with just air, okay? So if I do this, so let's say this, let's call it X. And let me change colors here. So let's start here. X equals 0, and then goes to X equals 3 millimeters, right? And right here, it's going to be 10 volts, and down here is 0 volts, okay? So here's 10 volts, and then let's make that 1, 2, 3, okay? So at X equals 0, it is 10 volts, and at X equals 3 millimeters, it is 0 volts. What does it look like in between? Well, it's a parallel plate capacitor. It's constant. That wasn't good for me. It's constant, and the slope of that, right? So remember that E equals negative dV dx, right? And so if I just care about the size of the electric field, then, throw some absolute values on it and it's cool. But really, we're looking at delta V over delta X, right? So what's the magnitude of the slope here is 10/3, right? Volts per meter, or Newton per coulomb, okay? Cool. Now, let's look again. Oops, I'm still in blue. I wanted to do black. So now, let's do this again. This is 3 millimeters. Oh my goodness. And then they threw a 2 millimeter guy in here, and it was metal, right? So hopefully you see that that means that this is 0.5 millimeters, and oh wow, that's a really amazingly drawn diagram. Yeah, okay, so that's 0.5 millimeters, and then 0.5 millimeters on the bottom there. So let's do this again. Okay, so just sketching out my axes there. So hopefully you see that it starts at 10, and it goes down to 0 by the time it gets down to 3 millimeters, okay? But what is happening? Well, the question you need to ask yourself is, what is happening in here? It's metal. It's a conductor. The potential is not going to change when it's in there, okay? That means the electric field is 0. Electric field 0 means the slope is 0, right? It's the potential is constant, okay? So when does that happen? Well, it's gonna have to do half of its voltage, 9, 10. Oh, I did not organize this well, so this was like 5 volts. It's gonna get there right here, and then it's gonna be constant until here, and then it has to go there. So our graph is gonna look like this, because it has to do 10 volts over 0.5 plus 0.5. So over 1 millimeter. So the slope of these guys is going to be 10 volts over, right, 1 millimeter. By the way, this was volt per millimeter, my bad. So this obviously is bigger, 10 thirds versus 10. 10 is a bigger slope, and this, therefore it's a bigger electric field. And it's because it has to go over that in a smaller distance because it's constant in here. So hopefully you see how this ends up just looking like a reduced distance of 1 millimeter. It's not, a constant thing. It's not a constant electric field of 10 volts per millimeter. It is this piecewise function. So hopefully that helps you sort of think through some of these problems.